Hello, good morning, everyone. Welcome to the Southeast Climate Monthly webinar series and our first webinar for 2021. My name is Meredith Muth from the National Integrated Drought Information System, NIDIS. This webinar series is brought to you on behalf of NIDIS, the National Weather Service at NOAA, and the Southeast Regional Climate Center. Today's agenda and speakers include first, a climate overview and tropical update from David Zierden at the Florida Climate Center. Then will be followed by a water resources overview from Jeff Dober at the Southeast River Forecast Center in the National Weather Service. Then an agricultural impact update from Pam Knox at the University of Georgia. And finally, we're fortunate to have a special presentation today on living with fire in the Southeastern U.S. from Dr. Holmes and Dr. Noel from the Florida State University. And as a reminder, we will have a question and answer period following the webinar. Please feel free to enter your questions or comments at any time in the question box. We also have on hand a number of experts to answer any questions related to climate in the Southeast. And also a reminder that we will be sending out a recap email by tomorrow to all registrants that will include a YouTube link to this webinar recording. With that, we'll go ahead and get started. Our first presenter, David Zierden, who will give an update on climate conditions and outlooks in January.
Okay, yeah, thank you very much, Meredith. And I'd like to begin with a recap of the calendar year 2020, a year we're all glad to see end. However, I'm not sure 2021 is off to a much better start. But with that in mind, let's review temperatures across the U.S. in 2020, continuing a warming trend. Every state in the union was warmer than normal in 2020. However, no state set a record as far as warmest year on since 1895. I thought Florida was going to be close and was certainly way ahead of the pace through November, but a cold December brought us back to just second place. But we do see that there are 10 different states that ranked as second warmest. The Northeast Seaboard, Florida, Arizona, New Mexico, all ranked as second warmest. And so it just continues this warming trend that we've seen in the last decade or more across the United States. On the next slide, we'll take a look at precipitation in the calendar year 2020. And we see kind of the haves and the have-nots, where the Western U.S. and the Southwest were very dry. Nevada and Utah recorded their driest calendar year on record since 1895, whereas the Southeast United States was very wet, where all the states colored in the darker green are in the top 10 wettest years on record. So kind of a split across the country between the haves as far as rainfall and the have-nots. On the next slide, we'll start taking a look at a little more, one other thing to remark on. The US did see 22 different billion-dollar weather or climate disasters in 2020. And there's a very good report by NOAA's NCEI that, if you follow the link on the bottom, but these billion-dollar disasters included 7 different tropical systems, hurricanes or tropical storms that impacted the Gulf Coast, Florida, and the east coast of the Carolinas. Some other highlights include the record-setting wildfires in California and Oregon this summer and fall, and also this might be the first time a derecho qualified as a billion-dollar weather disaster, the derecho that really impacted Iowa and the upper Midwest. So you can find more information at this report through NOAA. So on the next slide, we'll start taking a look at a little more recent weather and climate. On the top left are the temperature anomalies for December of 2020, state by state, statewide averages. And we'll see that the upper Great Plains were very warm. North Dakota experienced its warmest December on record. However, I'd like to call attention to Florida, which is colored blue. So Florida actually experienced a colder than normal month of December, and it's the first colder than normal month in the state since March of 2018, over 2.5 years. We've also seen some winter weather across the Southeast, some snow and a white Christmas for the Southern Appalachians, the North Carolina, Tennessee, even parts of South Carolina. And on the bottom left, it shows a snowfall accumulation map for just the past 48 hours, showing accumulations of several inches across central Texas, northern Louisiana, and northern Mississippi. So we have experienced some winter weather. On the next slide, we'll take a look at the past 30 days, and these are the temperature anomalies or departures from normal over the last 30 days. And since we've seen a warming trend the first week of January across Florida and the Southeast, temperatures over the last 30 days have returned to close to normal over Florida. But as we get further and further north into Georgia, Alabama, and the Carolinas, we see much warmer than normal over the last 30 days. On the next slide, we'll take a look at rainfall anomalies over the last 30 days. And we see we've had plentiful rainfall, very heavy event across the Florida Panhandle and southern Georgia with a stalled front last week. Also very heavy amounts, 4 to 6 or 7 inches above normal across the Piedmont of South Carolina and North Carolina and into Virginia. So on the next slide, we'll take a look at our friends in Puerto Rico and the U.S. Virgin Islands. The top graphic just shows average temperatures for the last 30 days, which range in the 70s across Puerto Rico and most of the area, which are very close to normal, not a lot of variability down in the Caribbean. And then the bottom map, we see rainfall totals for the last 30 days, which again are range from a little over 1 inch in the British Virgin Islands to up to 4 to 5 inches across Puerto Rico, but again, close to normal for this time of year. On the next slide, we'll take a look at the drought situation, which as much of the last several months or even longer, we've been relatively drought-free across the Southeast United States. This is the current U.S. drought monitor showing small pockets of D0 or abnormally dry across North Florida, coastal Georgia, even central Georgia, central Alabama, but these are just small pockets where things are a little drier than normal, but for the most part, we've been drought-free for the past fall and even summer across the Southeast United States. So on the next slide, we'll start taking a look ahead, and we'll begin with the 7-day quantitative precipitation forecast from the National Weather Service. And this shows we are looking forward to a drier period with very little rainfall or precipitation forecast across much of the eastern United States in the next 7 days. On the next slide, we'll take a look even further ahead in our seasonal forecast, and we always do this by looking at the state of the Pacific Ocean. And we are still in the midst of a very well-developed La Niña, or colder than normal ocean temperatures, sea surface temperatures across the equatorial Pacific, as we see shaded in the blue on this sea surface temperature analysis on the top. Again, the coldest anomalies are in the central Pacific now, but still a very well-developed La Niña. On the bottom is our Nino 3.4 index, which even went into the strong category back in November and early December, but we're still maintaining anomalies of around -1 degree Celsius across this Nino 3.4 region. And on the next slide, with such a well-developed La Nina in place, it's virtually certain to continue through the winter months, December, January, and February. As we get into the spring, the March, April, May season, the probability of continued La Nina conditions are still at around 65%. But as we get into the Northern Hemisphere summer, those probabilities fall to close to climatological probabilities. So this La Nina should begin to wane as we get into the spring and early summer, as is the normal life cycle of these El Nino and La Nina events. And over on the right shows the different model predictions for sea surface temperatures in the Nino 3.4 region. And all of the models are pretty consistent in showing warming sea surface temperatures as we get into the spring and early summer. So on the next slide, let's keep in mind kind of what the canonical La Nina impacts are for the United States, and especially the Southeast. La Nina tends to favor a strong polar jet stream that usually configures with ridging over the western United States and the Pacific Ocean and troughing across the central U.S. But this leads to a storm track north of us up the Mississippi Valley and leaves the Southeast, especially Florida, drier and warmer than normal. Now I say these are the usual La Nina impacts in the winter months, November through March. And over on the bottom left is a composite of all the strong La Ninas showing rainfall, strong negative rainfall anomalies or drier than normal conditions when you group all the past strong La Nina events together, especially across the southern U.S., Texas, the northern Gulf Coast, and Florida. However, as we'll see on the next slide, this El Nino La Nina cycle is not the only game in town. And before I switch to that, this is the seasonal 3-month outlook from NOAA's Climate Prediction Center for the months of January, February, and March. And it shows that classic La Nina pattern of favoring warmer than normal temperatures across the southern United States, including the Southeast, and also a fairly strong forecast for below normal rainfall in the same area across the southern United States and the state of Florida and the Carolinas. And with this forecast in mind, on the next slide is the seasonal drought outlook released in mid-December. And it shows that much of the southern United States, either drought is forecast to persist where it's present in the western United States, or even to develop as we go through the winter and spring across the northern Gulf Coast and portions of the Southeast. But like I alluded to on the next slide, La Nina El Nino cycle is not the only game in town. Throughout the month of December and so far in January, we've been consistently in the negative phase of the Arctic Oscillation, or another way of looking at it is the North Atlantic Oscillation. And over on the top right is kind of a schematic on how we're more prone to more variable weather and dramatic dips and ridges in the jet stream during the negative phase of this Arctic Oscillation. And what it really means is it makes winter storms, winter weather, cold air outbreaks more likely over the eastern United States, the Southeast, and the state of Florida. And over on the left is actually the temperature departures from normal for the month of December across the Southeast. And you can see really strong anomalies over the state of Florida, 3 to 5 degrees below normal in the month of December, partly due to this negative Arctic Oscillation, North Atlantic Oscillation. Now, if that's not complicated enough, on the next page, bear with me, I'm going to talk about sudden stratospheric warming events, and along with those, a disruption or even split of the polar vortex. And this is really not my area, so any of these experts out here that if I say anything wrong, or you can clarify things in the question and answer, please do. But we are in the midst of a sudden stratospheric warming event over the Arctic. Just very simply, it's when the atmosphere at these very, very high altitudes is sometimes prone to quite suddenly warm up to 100 degrees Celsius change in just a few days, as shown on the top left graphic. It shows in the pink or purple bar is the temperature of the stratosphere above the Arctic as of recently, and you can really see the sudden warming. And in the blue line is last year's stratospheric temperatures, and we see an event that happened in February of 2019. So anyway, when we have these sudden stratospheric warmings, it leads to a weakening of the polar vortex. And so the polar vortex is more prone to drift southward or even split, as the map and graphic on the bottom left show happened last week. So what does this split polar vortex means? It means we're more prone to dramatic troughs and ridges in the jet stream, and which can bring Arctic air masses to lower latitudes. And we saw that in Western Europe just last week, the snowfall event in Madrid, Spain. And when this happens, it is a forecast of opportunity where you can predict more variable or more prone to these Arctic outbreaks for the next 4 to 6 weeks. However, we don't know exactly where these will occur. We've seen it in Western Europe in the last week, but it really hasn't affected the Eastern U.S. as of yet. But it really sets the stage for these kind of Arctic events to happen in the Eastern United States. Jeff Berardelli, who's a climate expert at CBS News, wrote a really nice article kind of detailing what's happening here, that if you follow the link, you can get more information there. But the bottom line is, between this negative Arctic oscillation, North Atlantic oscillation, and now this sudden stratospheric warming event, these are really kind of overriding the typical La Niña impacts we see in the Southeast and Florida, as we've seen with the colder than normal December, when the forecast was for actually warm temperatures, and also plentiful rainfall when the forecast was for drier than normal conditions. How long this will continue to disrupt the usual La Niña impacts, and will they start to take effect later in the year? That remains to be seen. So with that, we'll go to the last slide and summarize. 2020 was a very warm and wet year for most of the Southeast United States. The U.S. had a record $22 billion disasters in 2020. In more recent times, we've been slightly warmer and wetter than normal over most of the Southeast in the last 30 days. There are small pockets of abnormally dry or D0 over the Southeast, according to the U.S. Drought Monitor, but no widespread drought at this time. We are still firmly in La Niña conditions in the Pacific Ocean, 100% chance of continuing through the winter, and a strong chance that it will continue through the spring. And based on the La Niña, the CPC seasonal forecast favors above normal temperatures and below normal rainfall. However, we do have the wild card of this negative Arctic North Atlantic oscillation, and now this sudden stratospheric warming and polar vortex split that's really playing havoc with the typical La Niña impacts. And we'll still keep a close eye, as drought could develop later this winter and into the spring if La Niña re-exerts its dominance.
Great, thank you very much, David. I'd now like to turn the presentation over to Jeff Dober from the Southeast River Forecast Center to speak about current and predicted water resource situation. Thank you, Jeff.
All righty, thank you, Meredith. And here you can see this is the latest stream flows across the Southeast, 28-day average stream flows from the U.S. Geological Survey, one of our key partners. And you can see in that map, the Southeast map, we're well above normal stream flows across most of the Carolinas, with near normal across Georgia and Alabama, and a mix of near normal to above normal across the Florida Peninsula. And overall across the Southeast, the South Atlantic Gulf region, we're collectively in the normal range, but right there just below the below normal range. And as you can see as well, stream flows, normal stream flows do increase here from January through March. That's pretty much our primary recharge period, to give you a perspective on those. So next slide. So, you know, you can see the reason why we've got these high stream flows across the Carolinas. We've been extremely wet most of the winter from the southern Appalachians, and even more recently across the coastal and Piedmont regions of South Carolina. This is the 60-day departure for precipitation. And as David pointed out, it's been really a wet year for the Carolinas. And so stream flows have been up most of the year, and they continue to be up. So if we go to the next slide here. And you can see this is the current river flood conditions, and we've got many rivers, coastal rivers, and the lower end river reaches, and bankful, or even in minor to we actually have a few isolated moderate impact floods going on right now across the Southeast. Go to the next slide. And this is really not atypical. This is somewhat typical this time of year. As we go, we're in week 2 of the year, and this is our river flood climatology for the Southeast. And this is representative of most of the Southeast, with the exception of the Florida Peninsula. The Florida Peninsula actually sees their river flood season during the mid to late summer period. But for most of the Southeast, we start to ramp up that river flood season in December, and it ramps up all the way into about mid to late March. And then we see a tail off across the region during the month of April and May. But we're in week 2 right now, and we're going to continue to see that a typical ramp up to potential river flooding across most of the Southeast. And we see it right now, as we just showed, we showed you the previous map. We've got a number of river floods currently active. We go to the next slide. So here's the overall stream flow forecast for the month of January, and really not much change from our December webinar as far as the forecast moving forward. We're looking at above normal stream flows for the most part continuing in January. As David pointed out, typically with the La Niña conditions, most of the Southeast would see below normal stream flows with La Niña, but in this case, and he sort of described it very well with all the other things besides La Niña. Right now, stream flows are not acting typical of La Niña situations, and so right now the forecast for January is to continue to go along with the trends, above normal stream flows across the Carolinas, and continued close to above normal stream flows in the Florida Peninsula, and then near normal stream flows across Alabama and Georgia. This is typically the dry season for the Florida Peninsula. So above normal stream flows in the Florida Peninsula don't mean too much as far as river flood potential, but they do mean quite a bit having above normal stream flows right now, as high as they are for North Carolina and South Carolina and Southern Virginia. As this definitely presents an inherent risk of continued river flooding going into the, as we go into the heart of river flood season in February and March. With that being said, though, we go into the next slide. We talk about February and March. We're sort of hanging on some of those same points that David pointed out, that maybe we'll go back into somewhat of a La Nina winter here. And we do see some drier weather really in the medium term weather forecast. So we're thinking maybe by February, March, we'll see near normal stream flows, which when I see near normal, stream flows are typically high during this time of year. And we still have a river flood potential threat, but we're hoping that the stream flows will back off a little bit with some drier weather going out toward February and March. And that's why we have a near normal stream flow forecast for most of the Southeast. And to give it a collective perspective, we go to the next slide. This is sort of where we think we're going to end up. This is, again, the USGS's graphic here, and we sort of put our probable stream flow forecast on top of that. And you can see we're probably going to be in that higher half of the normal range as we go through February and into March. If we're on the upper part of that envelope, then I think, then we'll potentially see, as we work into the late spring and early summer, maybe some above normal stream flows. But if we're on the lower end of that envelope, I think that will bode well into the late spring and summer. And that's the sort of stream flow forecast. Again, many of our reservoirs are running high and across the Carolinas, and so a lot of that water still has to be managed by the Corps of Engineers and the private utilities. But overall, stream flows remain above normal across the Carolinas and Florida, near normal for Georgia and Alabama. And then the stream flow forecast is more of the same for January, trending, but then trending near normal across the entire Southeast by February and March. That's all for the water resources section.
Great, thank you so much, Jeff. And now I'd like to turn it over to Pam Knox from the University of Georgia to talk about agricultural impacts.
All right, good morning, everybody. David's already set us up well, so I'm not going to spend a lot of time looking over the overall conditions. Just did want to note that all that rainfall that we've had from the Florida Panhandle up to the Northeast is a sign of where the storm track is this year. That storm track is usually quite a bit farther to the north in a La Nina winter. And this year, because of the sudden stratospheric warming and the really high amplitude in waves, that storm track has been pushed to the south. And so the storm track tells us where all the rain is likely to happen. And you can see that it's definitely farther south than we'd usually expect. And a lot of people have been surprised by that. You got to keep in mind that the La Nina patterns that we use for forecasting are based on statistics. So there's still variability from one year to the next. And this is one of those years when we've seen it farther to the south as far as the rainfall goes. We go on. No real signs of any drought that's likely to form, at least in the near future. You can see the lawn and garden moisture index there on the right shows everywhere except for the Florida peninsula is very wet. It will take some time for that moisture to go away, especially if temperatures are cool. And of course, things are still dormant. Florida peninsula is pretty dry, but that's not that unusual for this time of year. We go on. Some of the impacts of the recent conditions on agriculture. Frost now has covered everywhere really north of Orlando. So almost all of the Southeast has had frost. There are still some agricultural things going on. Strawberries have been planted in the warmer areas of South Carolina, of course, in Florida. And they often use covers to protect those plants. So you can see on the pictures on the left-hand side there, there's some frost damage on that strawberry plant. It'll grow out of that. It just caused some damage around the edges. The only time you have to worry is if the growing point gets frozen, and that really will kill off the crop. But they have to be very careful in monitoring those because those are sources of disease, and they have to remove the frozen vegetation. And on the bottom are some mustard greens that also got hit by frost. I was interested to read that the cold hurts green strawberries a lot more than the red ones because the red ones have a lot more sugar, and that acts as a natural antifreeze. So that was my little trivia tidbit that I learned this week. Cold temperatures really slowed the growth of winter grains, but the rain that we got did help improve pasture. So it's kind of been a mixed bag as far as that goes. Almost all the harvesting has been done for the pecans and the cotton. There's still a little bit out there to get, and the drier conditions lately have helped people be able to get into the fields. Of course, now they're looking ahead to next season and what they have to do. One interesting thing that we noticed this year was that the harvested cotton in the bales has a lot of seed coat fragments. And I've been talking to some cotton producers, and they think it's because we had rain during the middle of September associated with some of those tropical storms that really caused the bolls to burst and put those little outside parts of the cotton bolls into the cotton. And that reduces the value of the cotton because it's got all those little pieces of non-cotton in it. And so that's been something that we've been looking at in the last week or two, just to try to figure out if there's anything that can even be done about it. We go on. Another question I've been getting quite a bit lately is, how are the chill hours doing? You know, we started out with a very warm November, and the chill hours were way behind usual, but we've really caught up in the last month with these cooler temperatures. And you can see on this graph, this is from Peach County, Georgia, which is just south of Macon. There's a website there on the bottom that will allow you to pick your own site if you're in a different place. The yellow is the long-term average. The green is last year, and the red is this year so far to date, accumulated since November 1st. And you can see that we're now ahead of last year. And then the blue envelope shows all the possible outcomes based on previous historical data. So we're not going to be any worse than last year, most likely. We could be close to normal, just depending on how cold it stays from here on. And so one of the issues is that now we've had quite a bit of chill hours. That means the plants are primed to really break dormancy quickly if we go back into warmer temperatures. And I've heard from some producers that they're already starting to see some bud break. And so they're definitely concerned about that if we go into warmer conditions. So that's something that we're going to be watching for. We go on. Some of the threats to agriculture in the coming weeks. Well, we're going to continue to have some colder temperatures. I feel it profusely because my heat is not working very well at home, and so I'm sitting here all bundled up. But hopefully we'll go back to warmer conditions soon. And if you look ahead to weeks 3 and 4, the long-term forecast, it does indicate that we're more likely to see a return to more typical La Niña type conditions with the warmer and drier. It's hard to know whether the models are just picking up the climatology and trying to push things back that way, or if they really do see a change in the pattern. These sudden stratospheric can change things very quickly, and so it's really hard to know how long those conditions are going to last. And the rain, fortunately, we've had has been helping to hold off the development of drought that we were expecting. I think that's a good thing because it's not unusual to get a pretty widespread drought in the summer after a La Niña, and so this is holding that off. Go on. Just in summary, the recent wet conditions have improved the stands of winter grains and pastures. That's good because a lot of producers don't necessarily have a lot of hay to feed this year. The cold temperatures have slowed the growth of crops like strawberries, and it's caused some frost damage, but hasn't been excessive so far. Chill hours are still behind the long-term normal, but they are improving, and I think most places will get sufficient chill hours for either the peaches or blueberries. And then finally, we have not really seen a typical La Niña this year so far, and David's already talked about that. That CBS article, by the way, is really good, and so if you get a chance to look at that, I think that will explain it a lot better. And the expansion of the polar vortex could continue, but it may return to a more typical pattern later in the winter. So by next month, we should have a much better idea of what happened. But for right now, it's mostly a question of staying tuned. And that's all I've got, Meredith.
Great, thank you so much, Pam. And now I'd like to turn it over to our final presentation. We have a special guest presentation today on living with fire in the Southeastern United States from Professor Christopher Holmes and research scientist Holly Nowell from Florida State University. Chris, all yours.
Good morning. Thank you for the invitation to speak today. So I'll be sharing some work that our group has done on looking at fires and their impacts on air quality and climate in the Southeast U.S. So please go on to the next. So one of the key messages is that fires are really a natural part of ecosystems in the Southeastern U.S. This map here shows the average interval in years between fires in the era before Europeans settled in North America. And across the Southeast U.S., you see these oranges and browns indicating that fires historically occurred every 2 to 6 years throughout the Southeast U.S. and Florida. And you see much longer intervals between fires in, say, the Northeast U.S. and much of the Western U.S., where the fire return intervals would be every 50 years or 100 years or even longer in some areas. So fires occurred quite frequently prior to a couple hundred years ago. Next. When you think about wildland fires, this might be the sort of image that comes up of a fire damaging or destroying and replacing all of the trees and environment, but that's not really what we have most of the time in the Southeast. What we have looks more like the next slide. So this is a prescribed fire in a pine savanna, and this is a very common fire type across the Southeast U.S. So what you see here are really kind of a savanna type ecosystem where the tree canopy is kind of open. You can see the sky through the branches, and you have this grassland, ferns underneath the tree canopy. And the fire is sort of creeping along through the ground vegetation. It might scar the tree trunks, but they are fire adapted and survive perfectly well. These fires today are carried out for purposes of mitigating wildfires. So in other words, by burning off the fuels before they accumulate, you can prevent damaging wildfires or at least make them easier to control when they do happen. This is also carried out for purposes of land and wildlife conservation. Many of the species in the Southeast are well adapted for fires and flourish when fires burn an area frequently, and also for purposes of forestry, for if you're trying to grow a timber crop to remove competing vegetation. That's not the only kind of fires we have in the Southeast, of course, and the next slides show some others. So next. We have an agricultural fire here. This is showing sugarcane. In Florida, this is done for removing unwanted vegetation, for preparing the fields for harvest or weed control. And next is another fire type. Next slide. Yep. So here you see a picture of timber and other vegetation piled up after clearing the land, which might be done for development or after harvesting a timber crop, and also after damage due to something like Hurricane Michael. And in fact, that's what this pile here is showing, is in the Florida Panhandle, piled up trees that were snapped during Hurricane Michael. And there's still a lot of timber like that has not yet, or it's dead, either standing or fallen and not yet burned off. And so that's a hazard in the Florida Panhandle at the current time, still several years after Hurricane Michael. But of course, burning that off can prevent that from becoming a wildfire hazard. Next. Our group, and this is the work of Holly Noel, who is on the call with us, has used the fire permit records from the state of Florida to compile a sort of atlas of what fires look like across the state. And this is actually very similar to other Southeast U.S. states, but Florida has, in general, more comprehensive and a longer record of these sorts of fire permits. So what you see in the figure on the right is the percent of the land that's burned each year in fires. And wildfires are shown in the top right panel. And in general, you see that those percents are, below 5% across the state of areas burned in wildfire. Rather, what you see is that silviculture and agriculture are the main types of fire. And when we compiled what the average fire activity is in Florida, there are about 25,000 fires each year, burning about 2.5 million acres of land. Most of this is silviculture and agriculture. Only 8% is wildfire. And when you look at things on average, about 7% of Florida's land area burns each year. So that translates to a fire return interval of, on average, about 12 years. You can see that there are some parts of the state, like in the Panhandle, where the percent burned each year is in the range of 10 to 20%. And so there are parts of the state that are getting close to having fires with the sort of approaching the historical pre-European fire return interval. So it is then a question of, well, if one of the major purposes of these fires is to mitigate wildfires, are they serving this purpose? Are they meeting that goal? And this is something that we looked at. So go to the next slide. And this is one way of looking at whether these fires, prescribed fires, are meeting that goal. So the time series here shows in the top panel the area of fires that burn each year in Florida going back to 2004. And so the blue shows the prescribed fire area, and the wildfires are the smaller area in red. And we're comparing that to the Palmer Drought Severity Index. And I've highlighted some particularly wet and particularly dry years. And typically what we expect, like in the Western U.S., is that in dry years, you would have more wildfires. And that is what we see in Florida. The two dry years highlighted in red do have greater amounts of wildfire, but that's actually exceeded by the decrease in prescribed fires during those years, because prescribed fires are only carried out in conditions where it is safe to burn without the fire getting out of control. So in particularly dry years, prescribed fire is scaled back so that wildfires, while they may be greater than average, do not increase the overall fire area. In contrast, in the relatively wet years of 2010 and 2014 and 15, prescribed fires were scaled up, and wildfires were really quite small. So what we see is that overall fire area in Florida is steady or even decreases during drought years, and that's opposite of the natural controls that we expect climate to have on wildfires. And that's really an indication that this prescribed fire strategy is working. If you click again, so one of the key messages here is that the prescribed fire policy is offsetting and interrupting the natural moisture and climate controls on the fires, reducing the fire risks for the state. Now, we of course aren't the first people to note this. The Western U.S. is, I think, starting to recognize that prescribed fires can play an important part in mitigating wildfire risk. Of course, there were very damaging wildfires in California this year and also previously in 2017. And they do carry out prescribed fires in California, but if you click advance one more, this is the area of prescribed fires each year in California, about 50,000 acres per year. And of course, California is larger than Florida. So, Florida is burning 2.5 million acres. California is burning about 50,000 acres. So that's really showing the magnitude of the challenge for California and the Western U.S., that if they want to use prescribed fires effectively, it needs to be an orders of magnitude increase in the use of prescribed fires. Next. So because prescribed fires are so widely used across the Southeast U.S., we actually see that most of the fire area in the United States, or at least the continental or contiguous U.S., happens in the Southeast. And if we compare the past fire year in California, about 9 million acres of land burned in 2020 across the Western U.S. And that compares with some other very active recent fire years in 2015 and 2017. So very active fire years burn about 10 million acres in the Western U.S., with average being in the range of 5 to 10. In contrast, prescribed fires every year burn about 12 million acres. So, of course, wildfires are very newsworthy when they threaten people or livelihoods. But the reality is that there are an even greater number and area of fires that burn every year in prescribed conditions, and they aren't newsworthy generally because they are kept controlled, and therefore they don't threaten structures or cause evacuations. But nevertheless, they can cause air quality impacts, and there are about 60 million people living in the Southeast U.S., and nearly all of them within, say, tens of miles of landscapes that are burning frequently. And so there's a large number of people that are potentially impacted by smoke. And so my group has been interested in looking at the air quality impacts of those. And one of the key tools for mitigating air quality injuries is to have forecasts of air quality, so that we can forecast when the air quality may be particularly bad, and give out warnings to sensitive individuals. Now, we have generally pretty good air quality forecasts, but prescribed fires have been a challenge because these fires only burn for a couple of hours, and therefore where the fires are today can be quite different from where the fires are tomorrow. And air quality forecasts to date have not been able to take into account that variability in these fires. So on the next slide, I'm showing here a new strategy that my group is pursuing for predicting prescribed fires from weather forecasts. And this is the work of Angelo Agostra, a graduate student in my group. And what we've done here is that we have trained a machine learning algorithm to predict when fires will burn across the Southeast U.S. And we've trained it based on satellite fire detections from the NOAA hazard management system. And I'm showing just a example on the left here of one fire forecast that we made for March 8th of 2019. And so on this particular day, we predicted that across much of southern Georgia, there would be in any one of these areas, there would be a 30 or 40% chance of there being a prescribed fire. And just for contrast, across Kansas and Oklahoma and Missouri, we predicted pretty low probability of fires on this particular day. In contrast, the little postage stamp in the lower left corner is showing what the average likelihood of a fire is on March days. And we've checked the skill of these types of forecasts, and we find that they're really quite good compared with what is commonly used in current air quality models. We use the technical metric of the Breyer skill score, and we find that using this sort of a strategy, we can get 30% better forecasts than using climatology, and 60% better than the one-day persistence forecast, which is the commonly used standards in these. And if we look, since this is an algorithm that we can then dissect after we've trained it, we can see what the major important factors are. And this won't be terribly surprising to people who are familiar with prescribed fires, but of course, land use and social factors stand out as super important predictors of when and where fires will occur, as well as the atmospheric humidity. Precipitation is really important in determining where these prescribed fires happen. And that's both the accumulated precipitation over the prior week. Obviously, if it's very wet, then prescribed fires won't happen. But it's also important to know whether rain was predicted on the day, because if the Forest Service sees that rain is predicted, then they're not likely to burn, whether or not that rain actually comes. In contrast, we then found that a number of other meteorological factors are relatively much less important, like winds, temperature, mixing height, day of the week. These have some value in predicting prescribed fires, but not as much as the earlier ones. Next. And since this is a climate group, I wanted to point out some of the literature on what the risks of wildfire are with changing climate in the southeastern U.S. And I'm showing down in the figure here the central Florida climate taken specifically for Orlando, and highlighting on here the wildfire season in Florida is really in the summer months when we have the hottest temperatures, and the prescribed fire season is what's considered marginal fire weather. So and it happens in the cool season, and that means where it's dry enough that things will burn, but not so dry that they're likely to get out of control. And the solid red shows the current wildfire season. Now, advance one more. Now, the current projections for future late 21st century climate in the Southeast are that it will likely be warmer and may be wetter with more variability. And this comes from the National Climate Assessment and the Florida Climate Assessment. And so the implication is that the wildfire season may increase in duration by 2 to 3 months by the end of the 21st century. And in addition to the changing wildfire season, it's also projected that these changing climate conditions may expand savannas, ecosystems in the Southeast, and that savannas tend to be more fire prone than forest ecosystems. And an active research question in my group is how will these projected changes in climate affect our ability to carry out prescribed fires? So if the wildfire season is expanding, I think that is a management challenge, but I think it suggests that the way to address that challenge is by managing the prescribed fire season and prescribed fire practices to offset that potentially greater risk of prescribed fires. Now, I think that likely means that it may require greater prescribed fire capacity and potentially a longer prescription season, so that you're better able to take advantage of good prescribed fire conditions when they occur. And the next slide is the last. So this is kind of repeating many of the points that we made about the Southeast being fire prone, but at the same time, the prescribed fire policy in Florida seems to be interrupting some of the natural controls on fire and reducing risks for the state. And given the time, you can just leave these up and take any questions if there are any.
Great, thank you so much for that presentation on fire in the Southeast. I learned quite a bit. We are almost out of time. If you have any questions or comments, please feel free to put them into the question box. And if we don't get to it at this time, then we will certainly email you any kind of responses. A reminder that a webinar recording will be sent out in a recap email. Feel free to share this with your networks and advertise future monthly webinars with your colleagues and your networks as well. Our next webinar on February 9th will be a 2020 year in review in more detail from the National Centers for Environmental Information. Here's a registration link for upcoming webinars. A survey will pop up at the end when you close out. If you haven't taken the survey before, or even if you have, feel free to let us know if there are any specific topics you would like to hear more about, or any other suggestions on helping us improve this webinar series for all of you. And before we get started in the Q&A, for those of you who can stay online, that would be great. I do want to say congratulations to Alabama for their national championship, of course. Way to go, Southeast. Let's see. First of all, speakers, are you all able to stay on for a few more minutes? Or should I say, is there anybody who is not able to stay on?
This is Pam. I can stay on.
Great. All right. I'm going to start with, hopefully you can see the questions in your box. If not, the first one is related to air quality and fires. So I'll direct this to Chris and Holly. Do the air quality impacts due to fires affect primarily rural and suburban communities, or also more urban areas as well?
I think it's primarily the rural and suburban communities that tend to be closer to the areas that are burning. But I think one of the, there are cities that are not too far from large federal lands or Department of Defense lands that do burn. So I think, preferentially it's the more rural communities, but cities are not immune to these smoke effects.
Great, thank you. Any of our other panelists care to comment on that? Chip, I know you've been working with air quality issues. Okay, we'll move on to the next question. This is again related to upcoming fire season in Florida. Any expectation how this winter's weather will impact upcoming fire season in Florida?
Well, I think you can largely look at just what the precipitation forecast is, and David Zierden and Jeff Dober gave nice overviews of those, and we're looking at generally more wet conditions, which would tend to reduce the wildfire risk, although it's maybe a bit early. Question might be better posed to them, but how well can we predict the coming summer fire season? I think there's some uncertainty, of course, but we're not looking at higher than average risk at this time.
Yeah, this is David Zierden. There's also a wild card in that if Florida were to get a severe freeze with freezing temperatures extending well down the state, that can really kill or brown off vegetation and fuels, which could lead to certainly more active wildfire season. So that's a wild card that we have to pay attention to also.
Now, another sort of interesting diversion here is that you also sort of have to look at the past couple of seasons in terms of prescribed fires to see how much fuels might have accumulated. And in the last couple of years, there have been a number of factors that have prevented prescribed fires from burning as much as they might like to by the both private landowners and the U.S. Forest Service. There was a government shutdown a couple years ago, of course, COVID, and both of these things have caused prescribed fires in federal lands in particular to burn less than they have previously. So that has allowed fuels to build up somewhat more over the last couple of years, and so that is a growing hazard.
Okay, great, thank you. We're a little bit past the hour, so I think I'll wrap it up here. Again, if you have any other questions, feel free to contact me and I'll make sure that the panelists are able to respond directly to you. Thank you all for your time. Wishing all of you a very healthy and safe new year. And we look forward to hearing from many of you in February for our next webinar. And thank you again for all of your questions. We really appreciate them. Take care. And thank you to the webinar presenters, of course. We're really happy to have you. Have a good day.